exponential equation for an exponential function. So again, this means you're losing something. So you start out with some initial amount. So an initial amount means that when the time is equal to 0 minutes, or whatever, 0 years, you have an initial amount. We call that n naught, n of 0 or n naught. So when t is equal to 0, I have initial amount n naught of the substance, or it could be people, anything. Now, as time goes on, you can see that you're losing, right? The n values are getting smaller and smaller. So we call this decay. In science, we're interested in something called the half-life of a substance. So a substance is made up of atoms, and those atoms start to decay as the substance gets lighter and lighter as time goes on. So you start out with an initial amount n naught. So the half-life corresponds to the time it takes for the substance to lose half of its atoms. So at t half, that's the half-life, I only have half of the initial amount left, 1/2 n naught. So at this point, I have t half comma 1/2 of the initial amount is known as half-life. So your decay constant or decay factor k is what this is in the equation here. It's going to be less than 0 whenever you have exponential decay. It's going to be a negative number. E is equal to approximately 2.71828. We see that in the formula as well, E. So you know that already. You've seen it. So that's exponential decay. So we also have the opposite, exponential growth, which could be something like population growth, which we're going to see today. So if you live in a city, if the city is popular, like the Silicon Valley, the Bay Area, everybody wants to live here, the population's expanding. So we say population growth. So instead of losing, we're gaining. So as I start out with an initial amount here, 0 n naught at time t equals 0, there's a certain number of people living. As time goes on, I see the number goes up. So instead of having a half-life, we're going up. So we're going to have something called the doubling time is of interest to people in the sciences. So that's how long it takes for the initial population to double. So at that point, we're going to have twice the amount of twice the initial number comes at that point. So 2 n naught for that instead of 1/2 n naught for the decay. So the equation is still the same, n of t equals n naught e to the kt, but your growth factor instead of a decay factor is going to be positive. It's going to be greater than 0. So that's kind of the idea behind it. These are exponential equations and these are the graphs that correspond to these equations. So I'll give you a couple minutes to copy this, and then we'll look at some examples.